Swayam Prabha. Digital India. Educated India.
All right, good morning. So welcome to you. We've got about almost half the people in the classroom. I hope everybody else is on Zoom. We will maybe break you into breakout rooms later on Zoom, depending upon timing and how things go. Or you might just have to do a few things individually. Um, so we're going to go back to talking more about circular economy. You know, we've been building and introducing pieces and parts of that to you since the first day. And so today we're going to dive in a little deeper about, well, how do you actually do that? What are the strategies that you might take to reduce your environmental impact? And then that will be useful for your project because that's where you want to get after you sort of figure out what the environmental impacts are that you are concerned about or the life cycle stage that you're concerned about on your project, then this will help you maybe suggest some changes. So just I want to start a little bit on a review. And so I've got this broken into two parts, and I might not get done with the whole first part before our break, but then I'll finish that up, and the second part is a little bit shorter. So this first set of slides might go past our break. So we've talked about some different frameworks, cradle to cradle and circular economy. They're both the same thing, just saying that we want to keep materials and energy in our working economy as much time as possible. So that's the sharing, the reuse, all of those, the recycle, all of those words that mean we're not letting it get out of the cycle and ending up in a dump where then, you know, decades later you have to dig it up and put a lot of energy and effort. That's just a cost, right? It's much better to keep it in the economy and keep it moving. And that's true for energy too, like waste heat. If we can find ways to use that, that keeps it in the economy rather than leaving. So the other part of the circular economy and cradle to cradle is thinking about using more bio-based materials as long as we, rather than fossil or, you know, non-renewable materials, as much as we can without depleting that renewable resource, recognizing that like biomaterials, there's only so much grow that you can grow, right? There are a limited rate of growth, and so you can't cut faster or harvest faster than what grows. So those are the two essential elements of the circular economy. So let's just talk, just briefly review the history. You know, until about 20 years ago, maybe 30 years ago, we were in this exploit and deplete sort of mentality with industries, and some industries are still there, right? They're not worrying about any of this. They just want to make a profit. And that's all that they are thinking about. And it's not economically viable, right? They would be doing economically better if they sort of thought a little bit more. Right now, we're sort of in this sort of sustain what we're trying to do. So we hear the terms net zero, less harm, collaborative, ESG, prosperity. So it's more of a sort of combined human and planet-centric, right? Which is what sustainability is, with humans being both the social and the economic. But where we really need to get to remember that first day with what Professor Indu showed us with meeting the planetary boundaries, if we really, truly want to sustain our Earth and sustain our life on the Earth, we need to think about this regeneration and regenerative approaches. Has anybody heard that term before or applied to any industry or?
Generative farming.
Farming, absolutely. I'd say that's where the most progress has been made. So in my part of the world, that means that you have cows who are out in the field, they're pooping on the field, then you put the chickens out in the field, they eat the undigested grain that's in the cow poop, but the nutrients go back into the soil, and then you grow crops after it's been fertilized and basically weeded by the chickens. So that's regenerative. You're not adding pesticides, you're not adding nutrients. And it also, with better growth, you don't need to add as much water. If the soil is healthy, the soil retains more water. So that's a great example. Anybody else seen this term used in anything regenerative, anything other than agriculture?
Radicals also they're using regenerative stem biology.
Okay, right. So that's a very different approach, right? That's to improve medical care. So she said uh, stem cells, different stem, not science, technology, engineering, math, stem cells, using those to regenerate organs and different body parts. So that's a way to improve healthcare. But it's like do better with less. So it's net positive, right? Not zero. We're getting to net positive for energy production and things of that sort. And it's thriving. It's not just prospering, but it's thriving. So this is sort of a world that we can look forward to. And it is planet centric rather than sort of a human planet balance. But the net result of being planet centric is that our lives will be better as well because the earth is capable of supporting us and whatever our ways are. So these are sort of some of the historical contexts, both past, which I introduced on the first day, but also looking forward. And so right now, today, we're in that sort of middle category. But the more we can do to think ahead as well, because some of the things we design, today we're going to talk about design processes, some of the things we design for 30 or 40 or 60 years, right? Buildings, roads. If we can design those for this green future shown here, we will be better. If we design them for today, then by the time we're 30 years out, they're going to be not where we want to be in this more regenerative place. So we have to think about those things. So it takes a different way of thinking. Even though the projects we're working on, we're sort of in this yellow zone, that's all you can do in this, the time period that we have. I just want you to think a little bit more broadly. All right, so we've talked about all these words: remanufacturing, post-consumer, pre-consumer, recycling, reuse, non-toxic, use of organics. So I think you get the cradle to cradle or circular economy philosophy, right? Everybody's on board? So now let's think about how do we do that. So the first, remember I told you this first cradle to cradle document came out in 2002. So this is about the era, right? So 2 decades old. This is from that first book. So these were the sort of the first set of rules that you might follow. We're going to go beyond this, but just to give you some idea of the starting point. So get free of known culprits, things that we know are bad, like mercury. So some group has mercury or compact fluorescent light bulbs, right? So that project, yes, right? You've got that project. What's in compact fluorescent light bulbs? Mercury, right? And so you got to be really, really careful. And if they break and you're in a small room, you don't want to be in that room with that broken light bulb because there's mercury in the air that you are breathing. So just get away from it. In India, can you still buy compact fluorescent light bulbs? Anybody buy light bulbs? Yes, no? In the United States, they've been totally replaced by LEDs. In part because the LED technology has progressed so rapidly in just like 5 years. But it does away with that known culprit, right? So how can we make a light bulb that doesn't have mercury in it? Well, we can make LEDs and sell LEDs instead. So I don't think you can buy compact fluorescents, at least not the things that you would screw into a typical light fixture. All right, so follow informed preferences. So this is like, having sustainability goals, like zero waste, zero water, organic food, eat organic food, save water, low flow fixtures. Those are all your informed preferences, right? Those are all better. So create a passive positive list, right? That's part of that same thing, your preferences. and activate it, right? So you can say, oh yeah, organic food's better. It's better for the environment. It's better for me. But it's only good to say that if you also follow through, right? So don't just talk about these things, but follow through and do them. And then reinvent. That's that big word. Reinvent gets us to that green zone that I showed on the first slide, right? Just to totally rethink the products in our systems and why are we doing this to begin with. And we're going to talk about that a little bit more, the big picture changes tomorrow. So that was the first one. And then as history has progressed, we've talked about this circular economy, eco-industrial parks. There were some images on, I think, I don't know, day 1 or day 2 notes that I didn't get to, but there's a place in Denmark that's doing that. Industries are sharing water, they're sharing waste heat, they're sharing gypsum, they're sharing all sorts of material and energy and water resources. Green technologies, we've seen some green technologies, right? The anaerobic digester, the fuel cells, the electrodialysis, solar, right? We've seen green technologies. Some of you are working on green technologies. And what our projects are sort of oriented around is this new concept of product use and product, what are we doing? What's the end of life? So this is all those R words. I have them in not just R words, but that list of 11 R words that Professor Indu showed you the other day. Just keeping them the circular economy. So that's sort of what we're talking about now. So pollution prevention. Yesterday, that my number one rule of pollution prevention, if you've got a really concentrated waste stream and a dilute waste stream, do not mix them together because then you got a whole lot of volume you've got to treat. So that's why I asked Professor Indu yesterday about the dye and the textile, and they're mixing that really, really, really concentrated material with something that's a lot less concentrated. And of course, we hadn't gotten to that slide yet, but that was their recommendation, is to not combine those. Because otherwise you have to oversize your treatment system to treat all this volume. And there might be reasons to do it both ways, especially biologically. But if it's any physical chemical treatment processes, that is like the number one rule of pollution prevention is don't make more polluted water than you start with, which is basically what that textile industry is doing. Design for the environment, that's what we're going to talk about today, and that includes disassembly, recycling, dematerialization. All of that's part of design for the environment. So we want to change the products or how we use them or how we make them or how we manage them at the end of life, something along any step in that life cycle, the raw materials used, any step in the life cycle, we want to change that to reduce the material and energy use, reduce the toxicity and the hazard of the materials. So anywhere in the life cycle we can fix. So when you think about your projects, it might not just be, the materials used. It might be, well, can we just use the lights less frequently? Can we generate less food waste? Those are things that are other places in the life cycle that are sort of outside of what you're looking at in your project, but might be very, very realistic changes that have a bigger impact than tweaking something. And so you really need to understand the life cycle impacts. And so that's why we have this as a tool, right? So we've got this ways of thinking about changing our designs, but then we've got the tools. I didn't know that these were the tools to actually assess, is this better? Because sometimes we make changes that don't end up being better, or they're better in a little sector, but worse someplace else. There are other tools too. Risk assessment. Has anybody taken a class in risk assessment? Risk assessment, probability and consequence. So risk equals the probability of something happening, better or worse, times the consequence. There's a lot of talk about that. We're talking about nuclear energy. In my neck of the woods, people are very, very concerned about the risk. And the risk can be horribly catastrophic, right? Like the Fukushima meltdown that happened after a cyclone and wave tsunami in Japan. absolutely catastrophic for the people who live in that vicinity, right? But globally, it's not catastrophic, right? So, and it's also very, very low probability, right? So that was a case. So very low probability, high consequence, local impacts. If you compare that to climate change, it's probability of climate change.
Very
Very high, right? Super high. It's happening right now. Okay. The consequence,
Coming in slower than the probability.
so it's maybe lower. The consequence might be lower. And the geographic reach,
global.
global, right? So we have a very high probability. Consequences will get worse and worse. Right now, they may be moderate, but they will get worse and worse, and a global reach. So when you think about if nuclear energy is something that will help to mitigate climate change, yes, there are risks, but there are also risks to our burning coal, right? There are risks to any of our energy systems. And so it's just people think about the risks of nuclear energy because of those very few, very low probability, but yes, they happen, catastrophic events. So it's not like they will never happen, but very low probability and localized. So it's hard, right? But that is another tool in our toolbox to think about our design for the environment is a risk assessment. And then also environmental costs, which we're not really talking about at all, but the externalities, right? The cost associated with that Fukushima disaster was billions. I don't know, maybe even trillions. I don't know a number. But the cost is some of the superstorm Sandy that hit New York City, which is very highly populated. That was billions, right? And so that's a climate cost. So again, there are ways to think about the costs of these things associated with the environment. So we're not going to do those here, but I just want to let you know that there are more tools in the toolbox to do this kind of work. Can we turn the AC up a little bit? I'm going to have to take my glasses off. I'm steaming up over here. The lights and standing. Okay. So what do we design, right? You're mostly engineers. I know you're not all engineers, but mostly engineers. We design things, we design processes, we design wastewater treatment plants. So here's just some things that we design, you know, a fleece sweater, a chair, a city and streets, biofuels and mixed with gasoline, all our food and food packaging. We design these things. Engineers design that. A refrigerator. This is a picture of a smart refrigerator. I don't know why you need to see a, you know, supposedly you don't have to open the door as much if there's a picture and an inventory of what's inside your refrigerator. To me, that's a first world problem that we don't really need to design those things, right? But anyhow, so there's a couple of examples, and you looked at some of these examples on day one when we looked at the Ellen MacArthur Foundation, right? The same sorts of things. So that chair, Patagonia, which makes fleece outerwear. So if you do a lot of outdoor activity in a cold climate, you wear stuff like that. They have been using recycled materials in their fleece since 1993, way before the circular economy, circularity, you know, was commonplace. And this chair, if you look at that chair compared to some of the other chairs, you still have so much less material, right? It's webbing. It's not inches of foam. I don't know how comfortable it is. It looks like it's got good back support, but they also use green energy, use recycled material, and you can send the packaging back. But that, of course, that uses transportation. But transportation, as long as it's not global, is often much less. So those are some examples of things that we design. And we're going to talk about a few city tomorrow, but we're going to talk more about chairs today. So remember, we've seen this picture in a couple of different ways. You've got to know if the challenge with your product is material intensive, or it's the end of life, or if it's how we use it. You need to know that about your product to know how to best fix it. So if you have a laptop computer and your biggest concern is the energy use while using it, what are you going to fix? that littlest of the blue bars, right? And so maybe it's a good thing to do, but your energy might be better spent thinking about the materials that it's made out of, how much of that material you need. You might still need some of those rare earth minerals, but can we use less, right? You might be able to cut that. And it's partly in the actual materials, but also where they come from. If some of those rare earth materials were recycled instead of mined, then that would cut that bar. But in an automobile, the use phase is most intensive, and therefore they're changing how much energy it uses during use would be the most important thing to do. It's not that you don't want to still work on the other things, but if you only have so much money and so much, brain power, put it to where your priorities are. All right, so we need to know that. Minimize. If you have less material in your product, then you have to pay for less. It's just like food waste, right? If you're not wasting that food, then you are feeding more people with the same amount of food and you don't have to buy more. So it's a huge economic benefit for industries. And sometimes that's how you have to talk to industries, not about the environmental impacts, but if you make these changes, you will reduce your cost. Or if you're removing toxic materials, you will reduce the cost of hazardous waste management and wastewater treatment if you reduce these hazardous wastes. So there's almost always sometimes there's a capital cost, right, to change. There's always a capital cost to change. But over time, the benefits of buying less inventory and treating less waste is really, really valuable. Or maybe even selling your waste, right? What your waste product might be useful to somebody else. Okay, so there's in design for the environment, two big categories of things we can do. We can change the product, or we can change the process. How we make it, how we use it, what we do with it at the end of life. So both of those things are possible when you think about the changes that you might make. And so product changes, so we can make a different product, right? Why do we need this? Should we be making this to begin with type questions? Those are pretty big questions, but also materials, less material, less toxic material, maybe bio-based. And for the process changes, some of my animations here didn't come through. In addition to the material changes, right, that results in a process change. You can change how you make it, the technology, how, your manufacturing line, you can add advanced manufacturing. Advanced manufacturing is the talk of a lot of robotics and automation and sensors and controls. That often increases efficiency greatly. How much of that raw material that you bought actually ends up in your product? Because it's more careful, there's less human error. So advanced manufacturing is a really good thing for design for the environment. And good operating practices, that's, again, when I started doing sort of pollution prevention was the first step in all of this in the 90s. Even when Indu was a student, and that's Laura Weber, we talked about a fellow student back then, going into industry and looking around, that audit, somebody talked about a water audit, right? That is a design for the environment, right? You go look, if that faucet's drip, 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 dripping, right? That is waste. It might be a faucet of water, but it might also be a faucet of, some more hazardous material or something more expensive. And so making sure the valves work, that, just things are working the way they're supposed to be working, because it might have been designed great, but it's not operating the way it was designed, the manufacturing facility or how we use it. So there's a lot that can be done, even inventory control, especially if you have inventory that gets obsolete. Food, for example, buy way too much food, you know this from your refrigerators, right? It's more likely that you'll have to throw some out. So if you control the inventory in your refrigerator and you eat it before it goes bad, then you're not wasting the cost of that material. The same thing is true in industry. You're familiar with your refrigerators, but the industry sometimes has the same problems. So those are, big picture, there's all these different things that we can do to think about your product, or the process. And these lists right here, most of these changes are just in the manufacturing side, but it can also be on the use or end of life side as well. All right. Yes, my animations definitely ended up in the wrong order. Sorry. So often you have all sorts of things you're trying to accomplish in a product change. Efficient, durable, disassemblable, recyclable, all of those are words, right? That's part of the product changes. Okay. I don't know if you've seen some of this. Many forms are designed for the environment, right? So industries in India right now are designing for zero water discharge. That's a design for the environment. Not necessarily, we heard yesterday, might not necessarily be the overall life cycle system's best solution, but that is a design for the environment approach. Design for zero something, zero toxic, zero energy, zero water, but also efficiency, maybe manufacturability. And this is something that's always been done. You want to design something that can actually be made and maybe made in a more efficient manner. So it's all sorts of design for, these are all designed for the environment. And we're not going to go through all of these, but I just wanted to let you know that there's lots of different approaches for this. All right, so if we are designing a product or redesigning a product, like you're thinking about in your projects, there is a design process. I think most of you are engineering. You've probably seen a design process in some form, but this is the design from about a product, a specific product, not design of a wastewater treatment plant system, although it applies there too. So you've got some planning, concept development, system design, detailed design. Then you want to test it, product ramp up. It is really, really important that design for the environment elements come through at the beginning, right? It's much easier to do this from the start of your design rather than redesigning a product, right? When you're thinking right now maybe about redesigning products, but this is really, you want to start it from the concept development. Those avoiding the known culprits, right? All of those things from the cradle to cradle list, and we'll get into more lists. There's all sorts of lists. So mostly this today's PowerPoint, I'm not going to go through all the details, but it's a resource for you to think about what those lists look like. But it's really important to do it at the start, and once you've manufactured or you've got a prototype and you test it, you don't just test as technically does it do what I want it to do, but did it meet my design for the environment goals? That's got to be part of that prototyping, pilot, whatever the steps are, you've got to check it again. You do not want to build a full scale and then go back and have to fix it at that point. If somebody says design for the environment, you want to do it at the beginning. All right. So, and the life cycle assessment really comes into play once you have a detailed design and some pilot testing. Earlier on, you can use some more of the guidelines, right? But you don't have data to do a life cycle assessment early on. But once you start to get a detailed design, you can model the system, right? You can look in the literature, even though you don't have pilot scale data yet, you do have the capacity to still do some level of life cycle assessment. All right, so we're going to dive somewhat deep into these material guidelines for design for the environment. All right, as I said, there's a lot of words on these slides, and I've got them more words on my slides than usual because this is a resource for you. We're not going to go through all of these. And anybody can call out well, pick one. Use screws and other fasteners that can be undone, right? Every time you build something with rivets, you cannot take that apart to reuse the material. If it's something that is screwed together, then you can unscrew it and take it apart and reuse it, right? So that just as an example. The same thing, there was a picture of, or maybe it's coming, of a juice box. You know, there was some juice box the other day. That's a multi-layer material that we really cannot recycle. And so if it was a single, and those flexible plastic pouches I showed you last week also, that's a multi-layer material. So every time you make something that all goes together in one, then it's really hard to take it apart. You can't recycle it. Somebody mentioned fiberglass recycling. I don't remember who or where. It was in the last week. So somebody here, but I don't remember if it was in one of the research tours or where. Fiberglass is really hard to recycle because you've got the fiberglass itself, but all sorts of epoxies that are hazardous and dangerous and toxic together. And so it's really very, very hard to recover the glass part. Same thing with carbon fiber material. It's a great building material, but then you can't really recycle it. So the more you can stay away from those multi-layer constructions that you can't take back apart, the better for recycling. Oh, there's my juicy juice box. All right. I know it was on one of the slides. So the alternative is just polyethylene, which can be recycled. So that is an example. They both function the same, right? You don't have the nice little straw. Maybe if you got little kids, there's more likely to spill from the bottle than the juice box. But in everyday purposes, the one that is easier to recycle has all the functionality of the other one. All right, so PET, same thing, is the easiest to recycle. So those water bottles are at least easy to recycle, but we don't do very well recycling them. In the US, only 10% of plastics are recycled. So probably get to that after break. Good guidelines. So using recycled materials, the more you use recycled materials, the more there will be a market, right? And so that'll make the circular economy only works if there's a market for those materials. You might feel great putting it in the recycle bin, and then it gets separated, but if nobody's going to buy that and provide some economic value for it, even though you did your part, the circle is not complete. So all pieces have to be complete. All of the rest of those we have talked about. All right, so we're going to do an activity here. And so people online, I don't know if we can go to Zoom. So how many people are online now? 9. Can we put them in 3 breakout groups? All right, so what we're going to do, remember that Herman Miller chair? And then down on the bottom left, that's a chair in my office. We are going to look at chairs to see what elements of design for the environment you might see in that chair. Either it can be deconstructed for recycling, or it uses minimal materials, or you think it's using plant-based materials, and you don't have a lot of time and you don't have much knowledge. We're not going to go search for the specs for these things. We're just going to look at chairs. So in this room, the chairs you're sitting on don't count, but there are 3 chairs up here. There are 2 chairs there, and there are some chairs in the back. So if we can split up into about groups of 3 or 4, so a couple of groups can come up here and move those chairs, as long as there's one group at each of these. I guess those are the same kind of chairs as these. So anyhow, go look at the wheelchair chairs. There's more up here. So maybe 2 groups on the black chairs and 2 groups on the chairs with the desk, or 3 groups, something like that. So just split up. I want you to go look at these chairs, turn them over, look, how are they constructed? What sort of design for the environment elements do you see or not see on these chairs? So it's going to be less than 10 minutes. So you can move fast. And so online, so who's doing the online? Bindu, so you're going to make 3 random breakout groups? Okay, I think with 9. And they can somebody can, if it has a camera, so somebody with a camera online can share, show their chair, and then people can try to talk about it. We'll see how well that works. All right, move. Move. You can be quick about this. All right, so greener materials. non-toxic, bio-based, low embodied energy, right? So even if they are from non-renewable resources like steel versus concrete versus wooden structures, right? Those are things, but chemically safe and healthy. So we're going to talk about that a little bit. You've already seen some embodied energy. Has many lives, right? So it's a material that you can use and recycle, and it gets recycled, and ideally not downcycled, right? It doesn't get made into but can get remade into the same material. That would be great. Is affordable, right? Sustainability includes affordable laws and labels. It functions well. You don't want to change materials, but to make something that is bio-based instead of petroleum-based, and yet it breaks down too fast, right? That maybe isn't solving your problem. So it still has to be technically effective, whatever that might be. And that it greens the whole system, not just like the product, but also the whole life cycle. So just an example I found in India, I was looking, so the Indian Green Building Council, which we heard about 2 days ago, I guess. So here's a paint manufacturer. They received a Green Co rating. So it's water-based paints, no lead or mercury, which sometimes added as part of the pigments, especially lead, and near zero volatile organic compounds. So you don't get that new paint smell, right? Or that new car smell. I don't know if you're familiar, right? Those are VOCs. Those are dangerous for you. You might like a new car smell. Oh, I've got a new car. But it's really dangerous. It's all the foam in your seating off-gassing volatile organic compounds that are not good. So anyhow, so there's just example of a product and a company who is committed to this. So embodied energy, we've already heard about. I made the slide before Indu did her stuff, but I just thought I'd leave it here. There are all sorts of lists of embodied energy and carbon dioxide output. There's one more list, right? You had a couple lists from, and there's some citations down at the bottom there, the circular ecology carbon footprint database, that if, right, we said that they're in Professor Indu's textbook. Well, if you don't have her textbook, there's a site that you might go if you're looking for information about the embodied energy of materials. And it depends upon, you've got to think about what your system boundaries are, embodied energy, right? If you're using a product, the embodied energy is sort of everything upstream, making it, but then it's also the ultimate disposal. But if you are a manufacturer of something, the embodied energy is really everything upstream of that manufacturer and then everything downstream of the manufacturer. So somebody's in the middle, whoever, whatever use phase you're in, and everybody else is the embodied energy. But that data is available. So I just want to talk a little bit. The European Union has a new safe and sustainable by design framework. There's a lot here, and it's just getting started. But they have increased. The European Union is, by far advanced in terms of rules and regulations for anything associated with public health protection and environmental protection. So they don't have lists yet. They don't have the ratings yet on product. They're just getting going. But on this right-hand side, you can see the things that they, and then the environmental impacts of the entire body. So it's very much a life cycle approach. And they are looking towards this too. So it's something to look for in the future, something to pay attention to. We're not quite ready yet to teach you how to use this yet because it's not quite there. But it is something that is up and coming because there's lots of people doing the same thing that you're doing here, is learning how to do this. And so this will be another great tool that will be available. It has more risk assessment built into it as well. All right, so back to all these designed for disassembly. We just talked about there, designed for repair, upgrade, durability. This came from a resource that I use. If there are any teachers in the group, this Venture Well citations down at the bottom, has lots and lots of resources for all of the stuff we are doing. So I would explore some of those. Now, long list for this that were way too much for for PowerPoint to put on here. But basically, you want to think about the product's components, how to keep it alive longer, right? The more durable it is, that's a key use, right? Just use before we think reuse and recovery. Just use it longer. Buy clothes that are made to not fall apart, right? Just use it longer is the number one thing you can do for the circular economy. And then enable a responsible end of life. So recycling and remanufacturing. And there's long lists for each one of these at that link. So we talked about this juicy juice, the juicy juice is not designed for recyclability, right? It might be designed for ease of use, consumer, it packs well, right? There are boxes. So if you think of cartons and transportation versus the top of the other bottle, right, that this packs a lot. So this is the details, as I said, that I am showing this to you so that you know that this is in the PowerPoint. So when you're thinking about your projects, you know, what does design for disassembly mean? Is it something that would be relevant to my product? You've got this whole list. So I gave you the big words, but I'm not going to talk about this in any more detail. But I just wanted to make sure that you have this quick reference guide, and the link to the original was on the other page. So durability is another big thing, right? If we can just use stuff longer and not have to buy new, that is the most important thing we can do for design, just for circular economy overall. So durability is really huge. So be tough, right? It's a tough material. This wooden stool is tough. The chairs with the padding, right? We know those seats are, people slide in and out of them. We know those seats are going to get worn. We know that those desktops are going to get scratched, right? Especially with that material. So design to be tough so that they don't scratch and don't have to be replaced. So there's all sorts of suggest those. So, and that's partly thinking if like if you have to picking up those desks, tables to sit down, that was easy, right? If there was a lot of force required, you could imagine over time that those might break. So thinking about the stresses on the materials and different parts, the more that you can reduce that, so you're not fighting your product. That it's just easy to use without forcing anything. So wear well, right? The finishes are attractive, but also aren't going to wear off. Encourage maintenance. Regular maintenance is really, really important. Like these chairs with all the mechanical parts. Yeah, I can imagine a squirt of WD-40. Is that something you know? It's a lubricant, spray lubricant in those moving parts once a year. That might make those, hydraulic things work better. So think about what is the maintenance and make sure that the user actually maintains and does whatever that is. So that's good. And just stay relevant. So fast fashion is not relevant, right? But if you buy classic clothes that are going, so for example, saris in India, right? They never go out of fashion, right? And do the fabrics or anything go out of fashion? Not really. So you can wear your saris for decades, the same thing, right? So thinking about how to make something that's not going to be fashionable for a year, whether it's like a little toy. Toys are, at least in the US, right? There's every season, there's a rush to buy the toy of the year. And then by February, those toys are forgotten. But everybody's got to have whatever the toy, I don't know, Bindu, is that something you're facing? The toy of the year, right? But then it goes out of fashion. So the stuffed animal that I saw back down there stays relevant toy. I still have a few of my stuffed animals from when I was a child. They're kind of fragile at this point, but right, those stay, that they don't go out of fashion. I mean, maybe you outgrow them some, but it's not like the toy here. When you think about that's timeless, right? The more that you can think about your in the economy for longer. All right, so what can we do for design for the environment? See, here's just another example. We've seen graphs like this before. So this is a t-shirt. The biggest impacts are on materials and manufacturing, and that's mostly the cotton cultivation, but also the use from washing, washing, especially if you use warmer water, lots of water, depending upon the efficiency of your washing machine. So the organic sweatshirt, these are sorts of things. So what are we going to do? And the sort of shaded blue and shaded yellow, that means because there's a lot of uncertainty, right? It depends upon the uncertainty. But we know we can do something to improve the materials. So we can choose more sustainable materials, right? Organic cotton instead of not traditional, but, factory farmed cotton, right? That would be a big difference. Making sure that we use it efficiently and we cut out those sweatshirt or t-shirt shapes in a way that there's not lots of little pieces of fabric left over that you can't do anything. Can design for durability, right? Making sure that the seams are well sewn and it's not going to get twisted. That will help to keep it going. Design for repair. So yes, if it rips, you can patch it. You can do something that's true with all clothes. And then the t-shirt, just change the culture to accept fewer washings, right? That would change that the most. So this is just an example of once you know what those life cycle stages are, or the particular elements of a life cycle stage that are causing the biggest challenges, you can try to figure out what to do about those challenges and come up with solutions. So this is sort of the level that we want you to think about in your projects, like a graph, sort of, even if it's not quantitative, but where are the challenges and what are you going to do about those biggest challenges? All right, so just to summarize this part, we need pollution prevention. That's, reducing waste, non-toxic substitution. We need to change our product and we need to change the process. Some of that might just be tweaks off the leaky valves, but that can make a big, might be really big, like change the basic whatever you're making. So all of to think about is long list. Some when you know that the picture rule to go through every one of those checklists where we are. So I do have some more to talk about, but conversation, comments about aspect of design, right? So now we're actually today starting to talk about how do we change things, ideally from idea, but even if you already have a product, manufacture or change it. Comments? So there are real two drivers for business, for one, but also public image, right? Like that's their that's on their front page of their website. Their public image is, but cost has to be efficient you can be with your energy, water, and material. You're going to save money. So often it's from factory farmed cotton, you're going to increase your price, right? Available, it's a higher cost material. So trade-offs, but you might get it into a different market. So there's also issues like that. So technology, often the technologies are there. Maybe they need to make them cost effective, like for bio. In the United States, we're still making the ethanol that we gasoline, 10% of it is from corn. When we started ethanol and gasoline, we thought that was going to only be, and then we were going to make it from all sorts of other biological. that never panned out. The technology was not an economically viable. Technology's there, but not balanced. We're still using it from corn, but that corn can be used for all sorts of food. So there's a lot of outcry. Corn is very environmentally destructive. If we had been using waste biomaterials, like ethanol, that would have been perfect circular. But it's been, I don't know, 15 years gotten there because of the technology, viable technology. Plastics are going to be with us forever. If we want that to be true, petroleum, right? Because all of that petroleum we're burning, we're not using that as a feedstock to make plastics. But if we could get away from some of the single-use plastics and think more about the plastics that are durable and have a function, like the chairs, right? That's not single use. That's durable. Plastics will always have a role in our environment, and we'll never get rid of all of that. And we'll never come up with enough use plastics for all of that. It's the single-use plastics, I think, that are more of an issue. All right.